Compare the oscillations in piano string and flute. Introduction. In this section, we will compare the oscillations of string and flute. Understanding the differences in the ways these instruments produce sound can help us appreciate the unique qualities of each and gain a better understanding of physics behind music. What is an oscillation? Oscillation is defined as the process of repeating variations of any quantity or measure about its equilibrium value in time. Oscillation can also be defined as a periodic variation of a matter between two values or about its central value. The term vibration is used to describe the mechanical oscillations of an object. However, oscillations also occur in dynamic systems or more accurately in every field of science. Physics of piano strings. How piano strings produce sound. Piano strings are under tension and when struck by the hammer, they vibrate and produce sound waves. The frequency of the sound produced is determined by the length, tension, and mass of the string. The longer and thicker the string, the lower is the frequency of the sound produced. Similarly, the more tension in the string, the higher the frequency of the sound produced. The strings of a piano vary in thickness and therefore in mass per length, with lower strings thicker than upper. Given two strings equally taut and heavy, one twice as long as the other, the longer will vibrate with a pitch one octave lower than the shorter. However, if one were to use this principle to design a piano, that is, if one began with the highest notes and then doubled the length of the strings again and again for each lower octave, it would be impossible to fit the bass strings onto a frame of any reasonable size. All but the lowest notes of a piano have multiple strings tuned to the same frequency. This allows the piano to have a loud attack with a fast decay but a long sustain in the attack decay sustainable resist. ADSR system. The three strings create a coupled oscillator with three normal modes. Since the strings are only weakly coupled, the normal modes have imperceptibly different frequencies, but they transfer their vibrational energy to the sounding board at significantly different rates. This is the fundamental frequency of oscillations. Oscillations in piano strings. When a piano key is struck, a hammer hits a set of strings, causing them to vibrate. These vibrations or oscillations produce the sound we hear. In a piano, the string oscillates in a complex pattern that involves both transverse and longitudinal waves. In pianos, each tone is created by three strings tuned in unison. Since this unison is never perfect, the tone becomes richer because of very slow beats. Note that three strings are needed to prevent the intensity of sound from periodically turning to zero. If the piano is out of tune, the frequencies of the beats become fast enough to irritate the listener. This is the oscillation of piano string. Physics of flute. Flutes are wind instruments that produce sound through the vibration of air. When a player blows into the flute, air is forced across the edge of the mouthpiece, creating a disturbance that sets up a standing wave in the column of air inside the instrument. The standing wave causes the air to vibrate at a specific frequency, which determines the pitch of the note produced. The physics of flute is similar to that of other wind instruments, but there are some key differences. For example, in a flute, the air column is open at both ends, whereas in a clarinet or saxophone, the air column is closed at the end. This difference affects the harmonics produced by the instrument. In the flute, the air jet in cooperation with the resonance in the air in the instrument produces an oscillating component of the flow. Once the air in the flute is vibrating, some of the energy is radiated as sound out of the end and any open holes. A much greater amount of energy is lost as a sort of friction with the wall. In a sustained note, this energy is replaced by energy put in by the player. The column of air in the flute vibrates much more easily at some frequencies than at others. Oscillations in flute. Flutes produce sound through the oscillation of air within the instrument. When a player blows across the mouthpiece, air is directed against a sharp edge, causing it to split and create turbulence. This turbulence sets up a series of standing waves within the flute, which are responsible for producing the sound. This is the oscillation of flute. Comparison of oscillations. Piano strings oscillate in a complex pattern with multiple harmonics due to the string's stiffness and tension. Flutes produce a simple sine wave oscillation due to the vibration of the air column inside the instrument. Conclusion. After researching different aspects of the piano, I have realized that there is a lot of more involved than just pressing the keys and having sound come out like I thought there was. A piano and flute has so many parts to it that it makes sound the way that it does. I also learned that there are many different waves that sound waves can travel through, although a piano uses longitudinal waves. Thank you.